Alright, domain and range. This is a really important section, because without domain and range understanding, it's pretty hard to do continuity, which leads into it's pretty hard to find the spots in which you have to evaluate the derivative, the different intervals on which you're continuous. And then, even further, you need to understand where something's continuous to do integrals, because you cannot integrate across discontinuities, and it's a mistake a lot of people make, and it all kind of ties back to this. You need to know where a function is not defined, and that's where domain and range comes in. So looking at our spots where the domain is going to be secretly problematic, where we actually have to find where the problems are. 1 over 0 is one of our cases. That's going to be most of the cases here, is 1 over 0 type cases. Square root of negative numbers. It's a negative. And lastly, natural log of 0 or negative numbers. Those are spots where our domain is limited without it being super obvious and told to us ahead of time or whatever. Our range is also going to be limited, but that is easier to evaluate within the problem. Alright, so domain of our first one, well, we have a fraction, so we're going to have a 1 over 0 case, and the spot, or the value that we cannot plug in for x, because it will make a 0 on the bottom of our fraction, is where x plus 1 equals 0, which is at negative 1. So all we say is x is not equal to negative 1. Sweet. Now, for a range, which we're calling f of x in this case, we have to say what's the y value that we can't be equal to in this case. Well, the way to think about the ranges of these fractional problems is to think about the horizontal asymptote, because that horizontal asymptote is something you're going to get closer and closer and closer to, but never actually touch. So in the case of 3 over x is getting bigger and 3 isn't. So our horizontal asymptote is that this thing is going to get closer and closer to 0, never reach it, so we can't be 0. Alright, 1 down. G of x here. We can plug in anything we want. The squared has no limiting factors, so I'm just throwing a fat all real numbers in there. A range. Now this is limited. This is an upwards quadratic whose lowest point is negative 7. So all we have to say is that g of x is greater than or equal to negative 7. And we got it covered. It's equal to because the bottom of our parabola is defined. There are cases where it's not going to be equal to, but this is one of those. Alright, our next one. We have a square root, so we're going to look at this second case here, the square root of a negative number. So we need to evaluate where the inside of our square root could be negative. So 3x plus 1 equals 0. That's going to be the spot where it switches from being positive to negative. Subtract 1 from both sides. Negative 1 equals 3x. And divide by 3. X equals negative 1/3. So negative 1/3 is the point where this switches from positive to negative. It's at negative 1/3. Our square root is defined because you can take the square root of 0. So our domain is going to be all x's that are greater than or equal to negative 1/3. Now we have to think about our ranges. Because this is a positive square root, we're just going to have positive values and 0 because we're allowed to take the square root of 0 and we get 0. So y is just going to be greater than or equal to 0. Not so bad. Well, the next one is the easiest one. 3 minus 2x. That's a line that goes on forever and goes through all points. Cool. All real numbers. Lines are easy money. Alright, next. Less easy money here. Ish. So we got a fractional case here, so we got to figure out where the bottom's 0. So I come over to the right side here and I set 2x plus 3 equal to 0. Subtract 3 from both sides, divide by 2, and I get negative 3 halves equal to x. So I just can't be equal to that. It can't be negative 3 halves. Oh, and I realize up here that I called this y errantly. This is actually h of x. So I'm going to come down here for q of x. And I'm going to say, okay, what is q of x not equal? Well, if you remember from our first example, in the case where we have fractions, q of x can't be the horizontal asymptote. So our horizontal asymptote is at negative x over 2x. The x's cancel. I get negative 1/2. And that's where our horizontal asymptote is. So this thing's going to approach negative 1/2, and so we can't be equal to negative 1/2. Not so bad, right? All right, next. Similar case, I'm going to set 6x minus 1 equal to 0, so 1 equals 6x, so x equals 1/6. That's our spot we're not allowed to have. X is not equal to 1/6. All right, and then I need to look at my y value and see what that can't be equal to, and that is our horizontal asymptote, so the ratio of the biggest terms on top and bottom. And so that is x over 6x, which is 1/6. And so our y values, or our r of x values, also can't be equal to 1/6. Not so bad. Alright, our last case is one with a constrained range ahead of time. It's telling us the output values are always between 13 and 17. So all we have to do is solve for where x, what the value of x is when s of x is 13 and 17. So over here on the right, I'm going to set 13 equal to 2x plus 7 and 17 equal to 2x plus 7. So 6 equals 2x and 10 equals 2x when I subtract 7 from both sides. And x equals 3, 5 equals x. So we're between 3 and 5, and I just say that. Now I use less than or equal to's because they were used here. If I just use less thans here, I would also just use less thans in my domain because it wouldn't include those points. And that's how domain and range works. It's really, for domain, you're looking for these problems up here in the corner. And for range, you're kind of just thinking about what the function can't possibly be because of its limitations. Whether it's a horizontal asymptote, because it's a fraction case, whether or not it's always greater than the point or less than the point for parabolas and for square root functions, or any other sort of examples like that. For exponentials, for example, it's always either greater than or less than its horizontal asymptote, depending on whether or not the exponential is negative or positive. If you think about an exponential, they're like this. And so if that horizontal asymptote is 0, we're just always less than or just less than 0, because we can't be equal to our horizontal asymptote. So yeah, that's how domain and range works.